1997, number 81. I've already drawn the picture for you. You have a railroad track and a road crossing at right angles. An observer stands on the road 70 miles south of the crossing point. So I'm going to draw someone here, 70 meters. So the distance from there to there, that distance is 70 meters. Okay. Then we're told there's a train traveling eastbound. So there's a train traveling towards the east. So there's the train traveling east. The velocity of the train, they tell us, is 60 meters per second. And that's a rate. So what's changing 60 meters every second? Something's changing. And the best choice is the distance from the road to the train. We'll call that x. That means the change in x as time changes is 60 meters per second. Okay, so we change this velocity into a rate. And then what are we asked to do? We're asked to find how fast the train is moving away from the observer. So the train to the observer is this distance right here. I will call that distance z, and they want to know, they want to know how fast z is changing as time changes. Okay, the other one I want to label here is this one. Now, you should hopefully realize that that distance is constant. That's always 70 meters. It doesn't change. So I'm not going to put a variable there because it's not a variable. All right, now I need an equation that involves x and z, and quite clearly, hopefully you can see it's Pythagorean theorem. So we're going to say 70 squared plus x squared equals z squared. Now the reason I put 70 here, because it's not changing, this person's standing there, but x and z are both changing, so they're variables. So since the train is moving, x is changing 60 meters every second. So x is actually a function of time. It's not a variable, it's a function. I'm going to put it as box, as in chain rule. And as the train moves this way, clearly z is increasing, so z is changing with time. So I'm going to say z is a function. Now we take the derivative with respect to t to get rates of dx dt and dz dt. Well, the derivative of 70 squared is 0 because the derivative of any constant is 0. What's the derivative of box squared? Because it's a function squared, it's going to be 2 times box times the derivative of box. Same thing of z, box squared is 2 box times the derivative of box. Now I'm going to start punching in some values that I know. So what do I know? Do I know x? Actually I do. They told us the train has traveled 4 seconds after it passes through the intersection. It's traveling 60 meters per second. So the position of the train after 4 seconds is going to be 60 times 4, or 240 meters. So I know that x is going to be 240 meters. dx dt, they told us, is 60 meters per second. Now, dz dt is what we're looking for, so we're going to solve for that, but I need to know z. But if I know x is 240, Pythagorean theorem says 70 squared plus 240 squared is z squared. I'm going to quickly in my calculator do that for us. 70 squared plus 240 squared. That's going to be 62,500. So z is going to be the square root of that. And it comes out to be 250. How nice. So I'm going to put 250 meters here. And I'm going to solve for dz dt. I'm going to multiply 2 times 240 times 60. I'm going to divide that by my 250 times 2, or divide by 500, and I get 57.6 meters per second is dz dt. Because you're going to get meters squared here, divided by meters, you're just going to, those will cancel and you end up with meters per second. So 57.6, BAMO, answer A.